Dear students, in our today's class, we are going to discuss about the difference between static allocation of memory and the dynamic allocation of memory. So before going to that, we need to remember few things. The first thing is the delete pointer. Delete pointer. What is meant by this delete pointer and how this delete pointer will work by using the new operator? Come, we shall see here. Memory that is dynamically allocated memory that is dynamically allocated using the new operator can be freed using delete operator. Now look here. Memory that is dynamically allocated by using the new operator. Okay. In our previous class, what we have discussed, that is new and delete operators. So here, how the delete pointer will work? The memory which is allocated dynamically by using the new operator, and that memory can be freed. It means the variables which are stored in the memory by using new operator, those variables are removed from the memory. Okay, this is called as freeing memory, making memory free. Okay, when we delete the variables which are present in the memory, so that process is called as freeing memory. Okay, can be freed using delete operator. Can be freed means the variables which are stored in the memory using new operator, those variables can be removed from the memory using the delete operator. Hope you have understood this. Then the delete operator calls the operator. The delete operator calls the operator delete function. Also operator delete function, which frees memory back, to the available pool. Okay, here one more thing. The delete operator will call the operator. What type of operator? That is delete function. And this delete function frees memory. Okay, calls the operator delete function. Then this operator frees the memory back to the available pool. Pool means from which the memory has taken. It will do that memory again free and return that freed memory back to the pool. So this is how the delete pointer will work by freeing up memory, means deleting the variables from the memory using delete pointer. This is the first step. And next thing we need to remember is that releasing dynamic memory. How can we release dynamic memory? Releasing dynamic memory. There are few steps for releasing the memory which is allocated dynamically. Releasing dynamic memory means the memory which is allocated dynamically. That type of memory can be called as dynamic memory. Now, how can we release this dynamic memory? Now, use delete functions. Use delete functions to free dynamic memory. To free dynamic memory as, okay, look here, use delete function to free dynamic memory as. How can we use this delete function? What's the syntax of using this delete function? Come, we shall see now. We need to use like this: delete IPTR. We need to use the delete function like this for deleting the dynamic memory. There are two types. Now we shall see. To free dynamic array memory, to free dynamic array memory, we need to use one syntax. That syntax is like this: delete, then we need to take array, then PTR. Like this, we have for deleting dynamic array memory. If arrays are stored dynamically in the memory, okay, this is called as dynamic array memory. For freeing this means removing arrays from the memory is called freeing. We need to use like this: delete, then take array option, then PTR. And the next, the last step is that to free dynamic structure. We need to follow one syntax here also. Okay, as we have used syntax for deleting, as we have used syntax for freeing dynamic memory, that is delete IP here. Then for deleting dynamic array memory, delete, then array, then PTR. Now we are freeing here to free dynamic structure. Here there is a procedure, that is syntax delete, then take the structure name, not struct, not the keyword struct. Take the structure name, it may be student or anything. Okay. I have explained you that struct student, we have taken a structure by this name. Struct is a structure, it is a keyword, and student is a structure name. So for this thing, we will take the structure name here, not the keyword struct, but we will take the structure name here. Hope you have understood these things, that is delete pointer and also the releasing dynamic memory. And now we are going to see about the difference between the static allocation of memory and the dynamic allocation of memory. Come now, we shall see the difference between static allocation of memory and dynamic allocation of memory, static allocation of memory, and dynamic allocation of memory. Dynamic allocation of memory. Now we will going to discuss about these two things. One is the static allocation of memory, another one is the dynamic allocation of memory. Remember this thing. This is the most important for your examination point of view. This may be asked for 3 marks. The first point here is here memory is allocated. Memory is allocated before the execution of program. Before the execution of program begins. See here, before execution means during compilation, at the time of compiling, during compilation. During compilation. Okay? We have discussed already this thing, that is during compilation. Okay, the memory allocation is done under static memory allocation. So we shall see now in dynamic memory allocation. Memory is allocated memory is allocated during the execution of program. During the execution of program. Okay, where here memory allocation is done before executing program, but here memory execution is done at the time of compiling the program. It means during execution of program. And the second point, no memory allocation or deallocation. No memory allocation or deallocation allowed. Okay, no memory allocation or deallocation. Actions are performed. Actions are performed during execution. During execution. See here, memory allocation is done only before the execution. So here, memory allocation and deallocation actions are performed during execution, but not at the time of execution. Okay, here it means no memory allocation and deallocation actions are performed at the time of performed during execution. This means at the time of execution, allocation and deallocation is not allowed. Allocation and deallocation is only allowed before the execution of program. Okay, see, the second point is completely related to first point. If you remember this in mind, you can write down easily. And next, here, memory bindings are established and destroyed. Memory bindings are established and destroyed during the execution of program. During the execution of program. Here, don't get confused. What is meant by memory bindings are established and destroyed? This means memory is allocated and deallocated. That is it. Then you don't need to get confused that what this means. Here, no memory allocation or deallocations are performed during execution. Here you can write memory allocation and deallocation can be done at the time of program execution. Okay, this is second point. And third point is here variables remain permanently alone. Always here variables can be allowed under static memory allocation. At any time variables can be allowed. Here, along with this, memory bindings are established and destroyed during the execution of program, and then allocated means memory allocation. Okay, next point in this section. Okay, this is the third point here, and here third point is little bit different. Okay, allocated only when program unit is active. Okay, now come to the point. Here variables remain permanently allowed. At every time variables can be allowed at any moment, but here variables can be allowed only when the program unit is active. So this is the meaning here. Allocated means allowing variables to store in memory. Okay, only when the program unit is active. But here allowing variables at any time permanently. Okay, and the last point, implemented using stacks and heaps. Implemented using stacks and heaps. What are stacks and all we have discussed in data structures, that is in your fourth chapter. That is the stack here. Stacks and heaps. Heaps means this is sorting and this is stack. And here how they are implemented. Implemented using data segments. have understood the difference between the static memory allocation and dynamic memory allocation. Implementation means development of static memory allocation. Here implementation means development of dynamic memory allocation. This will happen using stacks and heaps, and this will happen using the data segments. So these are the few differences between static memory allocation and the dynamic memory allocation. So these things you might have understood. No need to explain me again and again. So dear students, if you have any doubts regarding today's class, you can ask me personally. Thank you.